Okay, in AP Calculus, AB, finding the derivative of logarithmic functions, just took some questions and going to share them with you today. Maybe take this one. If f of x is equal to ln of x squared plus 2x plus 1, then then find f prime at x, okay? So I guess I would start with this, and once you get the rule, it gets pretty simple, I think. And the rule is just this, that the first derivative, right, the first derivative of ln of f of x is equal to 1 over f of x times f prime at x. And this is going to be a really important pattern to memorize later. So all I'm going to do is that. I'm just going to fill this in. So the first thing I'm going to do is I'm going to take 1 over x squared plus 2x plus 1 times the derivative of the inside. So here's the inside piece, right? So what this piece is right here is the derivative of the outside. The derivative of the inside is the derivative of this, which happens to be 2x plus 2, right? So is that all right? Now, of course, this is going to work out this way, isn't it? So let's look at this for a second. So I got so happy. I thought this was going to work out really, really pretty. And of course, it turned into something weird. So here it is. So f prime at x is equal to 2x plus 2 all over x squared plus 2x plus 1. But if you look at this just for a second, we can break this out a little bit, can't we? So look, we have greatest common factor of 2 here, so we have 2, right, times x plus 1. And why is that noteworthy? Because this is that, isn't it? This is x plus 1 times x plus 1, isn't it? All right, so then, of course, this simplifies out, this over this, right? And we have 2 over x plus 1 is equal to f prime at x. So I got really excited, and I thought this was just going to clean itself up really, really nicely, but it didn't, not as nicely as I had hoped it would. So sorry about that, but it worked out good. It's good that we saw that. Let's look at this one. Now, if you don't mind, let's look at this one. You know what? Let's look at this one. Here's a good one. I think you'll like this one. This is y is equal to e to the 5x plus 5 power. So again, what's the rule for this? Again, remember, I just can't overemphasize how important it is to memorize these rules. So if we have e to the f of x power, we can simplify that by the derivative of this is e to the f of x power times, hopefully you're going to start seeing a pattern here, times f prime at x. Okay? So that's all we're going to do. We're going to say e to the 5x plus 5 times, and what's the derivative of this, right? So now what I'm going to take now is I'm going to take the derivative of this piece right here, and of course the derivative of that piece is 5. And I think that what it was in this question is that we were actually asked to take it at a specific value, but didn't go over that, so here's that derivative. So y prime, the derivative, is 5e to the 5x plus 5 power. Okay? All right, let's do one more and see if we're getting anywhere with this, okay? So let's do this one. Let's do y is equal to e to the x sine of x. Now this one's a little bit different. Where we have f of x is equal to e to the x power. F prime at x, and this is we have to memorize, is also its own derivative. G of x is equal to sine of x. G prime at x is equal to cosine x, isn't it? Okay. So what are we going to do with this? All right, so we're going to use the product rule here. So product rule here. So it's the product rule. The product rule, of course, is that f of x times g prime at x plus g of x f prime at x. And we're going to, from here, if you haven't heard it 1,000 times, going to fill in the blanks. So the derivative of this, y prime, is equal to e to the x times cosine x plus sine x, right? Plus sine x times e to the x. Isn't that right? So this one, actually we're almost done with it. All we have to do is just clean this up a tiny bit. You can see that they both have shared factors, right, of e to the x. So we get e to the x power times cosine x plus sine x. Be careful, this is not cosine squared x plus sine squared x, because that has a different value, doesn't it? So there's your derivative. Okay? Good work.